This video will be discussing about statistical methods module, under which we'll be covering two important topics, that is correlation and regression. Firstly, understanding the definition of correlation. Let's take two variables x and y. Suppose if change in one variable affects the change in another variable, then it is said to be correlation. Or correlation is covariation of distribution of two distributions, say x and y or a and b, etc. Okay, so there are majorly three types of correlation. The first one is positive or negative. So change in any value would lead to either increase or decrease in the other value is called as positive or negative correlation. In simple correlation, if you're dealing with only two variables, then it is simple, and if the variables are more than two, then it is multiple. So the ratio of change between two variables is uniform, then it is linear, and if the ratio is not same, then it is called as non-linear. So as we have understood the definition of types, let's move on to Karl Pearson coefficient of correlation. So it is represented as R. Okay, so the formula is as follows: R is equal to summation x minus x bar into y minus y bar by n sigma x sigma y. So here sigma x and sigma y are standard deviations, and x bar y bar are so for x bar you'll calculate it as summation of x by n, and for y bar you'll calculate it as summation of y into n. Okay, so this is one formula. We have another alternative formula, that is R is equal to sigma x square plus sigma y square minus sigma z square by 2 sigma x sigma y. So this is the formula. Now here we have to write the expansions of sigma x square, sigma y square and sigma z square. So firstly, sigma x square is summation of x square by n minus x bar whole square. X bar value you know how to calculate from this, yes. Now summation sigma y square is equal to summation y square by n minus y bar whole square. So sigma x is done, sigma y square is done. Now what is z? Z, we have to remember that z is x minus y. So sigma z square is summation z square by n minus z bar whole square. So these are the important expansions of this coefficient of correlation formula. Next we have regression. So regression is an estimation of one independent variable or variate in terms of other, where x and y are correlated. So if x and y are correlated, then the best fitting straight line in least square sense are the regression lines. That is, the one regression line of defining the relation between y and x can be written as y is equal to ax plus b, where we define regression line of y on x. Similarly, x is equal to cy plus d is regression line of x on y. So regression lines are basically two lines which obey these straight line equations. So firstly, writing the regression line of y on x formula, y minus y bar is equal to r into sigma y by sigma x into x minus x bar. Similarly, regression line of x on y, x minus x bar is equal to r into sigma x by sigma y into y minus y bar. This set of formula can be used to find the regression lines when we know the value of r. Suppose you don't know the value of r, then you have another set of formula, that is y is equal to summation xy by summation x square into x. Here we are using capital Y and capital X. Capital Y is y minus y bar, and here capital X is x minus x bar. So these two formulae can be used when we don't know the value of the coefficient of correlation value, that is r. So yes, I hope all the concepts are clear. If you have any doubt, please do let me know in the comments. Thank you.